So in component 6, we're talking about polynomial and rational inequalities. So we're going to first start with our polynomial inequalities. Now with these, you can solve them both graphically and algebraically. So we're going to start by looking at it in terms of algebra. Okay, so if I want to know where is this function greater than 0, then I need to know what are the x-intercepts. Okay, so if I set this equal to 0, I would get -3. If I set this equal to 0, I would get +1. If I set this equal to 0, I would get +1. So our x-intercepts are at -3 and +1. Okay, now, because this is strictly greater than 0, these have to be open circles. Okay, because I'm not allowed to be at -3 or +1 because it's not or equal to, strictly greater. Okay, now greater than 0 means positive. So I want to know when is this graph positive. And in order to figure that out, we're going to have to plug in a number in each of these intervals and see if we get a positive number or a negative number. So the number I could plug in here would be -4. So if I did -4 plus 3, -4 minus 1, -4 minus 1. Now it really doesn't matter what number this is. I only care is it positive or negative. So let's just do some quick mental math. -4 plus 3, that's going to be a negative. -4 minus 1, that's going to be a negative. -4 minus 1, that's another negative. 3 negatives are going to give me a negative. So this area is going to be negative. Okay, now let's plug in a number between -3 and 1. You could pick any number between -3 and 1. Well, the easiest number is going to be 0, right? So 0 plus 3, 0 minus 1, 0 minus 1. So we've got a positive times a negative times a negative, which gives us a positive. Now let's plug in a number on this side, which would be 2. 2 plus 3, 2 minus 1, 2 minus 1. That's going to give us a positive, a positive, a positive, which will give us a final answer of a positive. So now that I know my positives and negatives, because this is greater than 0, that means I want all of the positives. So I'm going to shade anywhere there's a positive number, which is here and here. So these are my answers. So how am I going to write that? We're going to use our interval notation. So our answer is between -3 and 1, but then we have to stop. So it's between -3 and 1, but then we have to stop. Now because we cannot include these because it was strictly greater than 0, we have to use parentheses. And then because we stop, we use our U symbol. And then it starts back up at +1 and it goes on forever towards the positive infinity. So this is our answer. Now let's talk about how we could have solved this using a graph. Okay, well, don't we know that this is a 0 of -3 with a multiplicity of 1? So if I were to graph this, I would be at -3 with a multiplicity of 1. And then I've got +1 that has a multiplicity of 2 because there's 2 of them, right? So this has a multiplicity of 2. Now if I were to multiply this all out, we've got x cubed, which means we start at the bottom and end at the top. Odd multiplicity means cross, even multiplicity means bounce. So where is this graph greater than 0? Well, it's greater than 0 here and here. So between -3 and 1, and then 1 to infinity. These are open circles because we're not allowed to be 0, only strictly greater than 0. So here's all of our positive graph, which is the same answer. Okay, so let's look at number 2. So number 2, our zeros are 1. And then this guy can simplify because it's the difference of 2 squares to x minus 2, x plus 2. So we've got +1, +2, and -2. So on our number line, -2, +1, +2. Now, because it's strictly greater than 0, these are all open circles. And then we have to plug a number from each of these in. So I'm going to plug -3 in. So -3 minus 1, -3 minus 2, -3 plus 2, give us negative times negative times negative, which is going to give us a negative. Plug in a number here, let's say 0. 0 minus 1 times 0 minus 2 times 0 plus 2. It's going to be a negative, negative, and then a positive, which will give us a positive. Okay, between here, we could do 1.5. So 1.5 minus 1, 1.5 minus 2, 1.5 plus 2, positive, negative, positive, so that will give us a negative. Plug in a number here, 3. 3 minus 1, 3 minus 2, 3 plus 2, positive, 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 which will give us a positive. Now, because this is greater than 0, we want the positive, so our answers are here and here. So our final answer is -2 to 1 with parentheses because these are open circles, and then 2 to infinity. Okay, why don't you guys try number 3 and then check the answer key? I'm going to move on to number 4. So on number 4, we're going to have to factor before we can figure out what the zeros are. So let's start by looking to see if there's a GCF. Right, so if we look here, the GCF is x squared. So if I pull out an x squared, that leaves us with x squared plus 4x minus 12. Okay, well, this is a trinomial, so it multiplies to -12 and adds to +4. Okay, well, that would be x plus 6, x minus 2. So that makes our zeros 0, -6, and 2. So now when we go to our number line, we are at -6, 0, and +2. Now this time, because it's or equal to, these are allowed to be closed circles. Now let's plug in our numbers and see what we get. So we could plug in -7, so -7 squared times -7 plus 6 times -7 minus 2 would give us a positive. Remember, a negative squared is going to be positive. Positive times a negative times another negative is going to give us a positive. Plug in a number here, we could do -1. We're still going to get a positive here. Anything squared is positive. Positive, negative will give us a negative. We could plug in +1. Positive, positive, negative, we get another negative. And we could plug in 3. All 3 positives, so positive. So because this is less than 0 this time, that means the answers we want are the negative answers. So our answers here is anywhere there's a negative symbol, which is here and here. Now in the other problem, when we had to write this, we said -3 to 1, and then we had to stop it, right? And then we went 1 to infinity. Now that's because it's not allowed to be 1, right? So we had to jump over the 1, okay? Can't be 1. In this problem, we don't have to do that because it's okay for the answer to be 0. So instead of saying -6 to 0 and then 0 to 2, we're allowed to say the answer is just -6 to 2. So our answer is -6 to 2. Now, because these are closed circles, we're allowed to use brackets, meaning it can be -6 and it can be +2. So there is our final answer. All right, number 5. The first thing that we have to do is move our 16x to the 4th to the other side. So we get x to the 6th minus 16x to the 4th is greater than or equal to 0. Okay, now let's factor. We could factor out an x to the 4th, which leaves us with x squared minus 16. And then this is the difference of two squares, so now we can factor again, giving us x minus 4, x plus 4. So on our number line, we've got 0, and then we've got negative 4 and positive 4. Because this is a or equal to, these are going to be closed circles. And then we're going to figure out what are our positives and negatives. So why don't you guys pause and figure out the positives and negatives. All right, so hopefully you paused and did this work on your own. So here's the answers that I got. I got positive, negative, negative, positive. Because this is greater than 0, we want the positives, right? So our answer is going to be negative infinity to negative 4, right? Because this is going to the negative infinity region. Infinities always have parentheses. Because this is a closed circle, we have our bracket. Then we also have negative 4 to positive infinity, right? So negative 4 is a bracket. Positive infinity is always a parenthesis. Now, the reason I kind of left these separate is because you have to remember that this, because there is a closed circle, that's also part of your answer. I know it doesn't look like it, but because this is a closed circle, we also have an answer of just 0. Not 0 to anything, just 0, period. Okay, so here is our final answer. Negative infinity to negative 4, x equals 0, and then negative 4 to positive infinity. Okay, number 8, I'm going to start with you, and then you're going to finish it on your own and check the answer key. Okay, so first thing we have to do is factor out an x, which gives us x squared minus 3. Okay, now this is not the difference of two squares because 3 is not a square. However, I could look at it as, well, the square root of 16 is 4, right? So that's how we got these two numbers. Well, the square root of 3 is the square root of 3. So we could say this is x minus root 3 and x plus root 3. Now, technically speaking, if I ever asked you to factor, these are not proper factors because factors shouldn't have irrational numbers. However, for the sake of figuring out what our answers are, we're going to factor like this. So that means on our number line, we have negative root 3, 0 from this x, and then positive root 3. Because this is strictly greater than, we're going to have open circles, and then we're going to figure out our positives and negatives. So go ahead and finish this problem and then check your answers.